You can use implicit differentiation to find the second derivative of a function, and all it requires is that you do the process 2 times in a row. So in order to do it, you got to first find dy dx, and then we'll go back and take the derivative of the derivative using implicit differentiation in order to find this guy. So let's find dy dx first. Y squared plus 2y equals 2x plus 1. And we're going to take the derivative with respect to x. And using implicit differentiation, the derivative of y squared is 2y times dy dx, plus the derivative of 2y is 2 times dy dx. And on the right side, the derivative of 2x is 2, and the derivative of 1 is 0. So now we solve this for dy dx by isolating those. So let's factor it out. So we get dy dx, and what's left is 2y plus 2 equals 2. And then divide by 2y plus 2 to get that dy dx is equal to 2 over 2y plus 2. And if you wanted to make it as simple as possible, you could factor out a 2 in the bottom. These would divide, and you get 1 over y plus 1. So that's dy dx. So far, so good. And now what we need to do is find the second derivative. So to find the second derivative, we're going to take the derivative of the derivative. So we're going to take the derivative of dy dx. Now, what I would like us to do is rewrite this 1 over y plus 1. I think I'm going to use the power rule. So I'm going to write this as y plus 1 to the negative 1. But you could leave it as it is and just use the quotient rule. So here's what we're going to do. We're going to say, I know that dy dx is equal to y plus 1 to the negative 1. If I want to take the second derivative, I'm taking the derivative of the derivative. So the left-hand side notationally is just d squared y over dx squared. And now the derivative of the right-hand side is just bring down that negative 1, y plus 1 to the negative 2, and then the derivative of the inside is the derivative of y plus 1, which is just dy dx, because the derivative of y is 1 times dy dx, and the derivative of 1 is 0. So it may seem like we're done, except that we can do better, since I know what dy dx is, right? I just found it. It's equal to this. So I can just make a substitution and write this as negative 1. That y plus 1 to the negative 2 I want to write as y plus 1 squared in the denominator. And then dy dx is 1 over y plus 1. And then multiplying those, you get negative 1 over y plus 1 cubed. All right, so it was applying implicit differentiation twice plus a little substitution. A little substitution here. And now we've got the second derivative in terms of in this case, I guess just the y variable. So that's using implicit differentiation twice to get the second derivative.